All right, here is the part 2 of your 5.1 for pre-calculus. This is Mr. S talking. We just looked at this here, okay? Now this is called Pythagorean theorem. Now what you can do here is you can convert it to make it look different every time. So it might look different, but it's the same Pythagorean theorem. So first, I'm going to divide this whole thing, every single term, by cosine squared. So let's look at the Pythagorean theorem in that form if you do divide them by cosine squared. So cosine square, divide them all by cosine square. So the cosine square divided by cosine square is 1. Now sine divided by cosine, it's going to be tangent square. And then for the 1 over cosine, or the flip of a cosine, remember the cofunction? Cosine start with the c. The cofunction of a function that starts with the c is going to start with the s. So I'll call it secant square. So this is another form of a Pythagorean theorem. Okay? So that's how you write that form. Now you can get that and you keep it, or now if there's a need for me to change things around, you can change the top here or any line. Here's an example when I say it changes. For example, if I want to see a tangent by itself here, or if I come across a problem where it says, oh, change the tangent to something else, I can say, well, let's see, a tangent, I can change this. So you want me to write a tangent with secant square minus 1? I can do that because I can subtract 1 back here. So anytime you see a tangent square, you can write that. Now, the benefit of writing like this is this form here you can factor into 2 parts, okay? Into 2 difference of squares. You have a secant minus 1 plus the conjugate pair, or the evil twin of this minus, which is a plus. So that can be broken down anytime, okay? So if you see a tangent square, you can trade that tangent square out and get secant square minus 1. And then you can also break that down. Why are you going to get all that? That's when you need to simplify stuff, which is going to come up later on, okay? So I'm at about 2-3 minutes. So let me talk about what if I divide the Pythagorean theorem with not sine square, not cosine square like last time. If I divide this by a sine square, what would that be? Okay, it's going to look different, but it's the same thing. Okay, so this time I'm dividing it by sine square. All right, so it will look different. Okay, so it goes sine square here. So now cosine over sine is called cotangent. Since you have a square, so there should be a square for both cotangent. Plus, okay? So now you got sine divided by sine, that should be 1. And then you got 1 over sine. Now, remember, this is cofunction. Sine starts with the s. The cofunction of the function that starts with the s is going to start with the c. It's called cosecant. That's how I remember them. Okay, so once you write that down, that is, if you see cosecant square, you can trade that with this. Or if you see this, you can trade that with a cotangent. So it's back and forth. Now, another one that you might be saying is this, okay? Let me see, I'm trying to back off on my writing. Okay, this is a standard. All the time. This is going to be used a lot. This one in the box. Every time you see cosine squared plus sine squared, it equals 1. Just take my words for it. I can prove it to you in class with the calculator, or you can prove that to you for yourself here. Take a calculator and type in cosine of any angle, all right? So let's say you type in cosine of 20 degrees. I know it's not even on unit circle. And then you square that. plus the sine of 20 degree square, I will guarantee you that it's going to be equal to 1. It doesn't matter what number you put in there, okay? It will always get you a 1, all right? So anytime you see the sine square plus cosine square, anywhere in your problem, on the homework, or on a paper somewhere, if this one comes up to you on the street, you'll say that equals 1. Get it? All right. So I'm going to pause this one. I'll go to the next example.